All right, welcome to your first geometry video that you're watching from home. As explained in class, what this is doing here is we're doing a flipped classroom, so you're going to be watching this video at home and taking your notes there, and then you will come to class and we will practice some of the information that you learned. This video right here is going to be very heavy on vocabulary because we've got a lot of new terms that we need to know. And so we've got them listed here. We're going to talk about what points, lines, planes are, what line segments are, angles, and we'll talk about collinear points, coplanar points and lines, and then intersecting lines and planes. Some of this will be covered in the video here, and a little bit, some of the other stuff will be covered then in class tomorrow. Notice here that it says to be able to identify and to model. So identify, being able to look at a drawing and be able to find a line and a point, and then modeling means to actually draw it out. So you have to draw out a line, you have to draw a line segment. So in class, we created a foldable for you to use to help with your note-taking ability here. So go ahead and grab that and we'll get started. So the first thing that I want to do here is to define what a point is. A point is not just a dot like people think. It's a location. It does not have any shape. It does not have any size to it. So when you think about a point, we think of these little dots here. And there's no size to them. There's no shape to it. But we do associate them with letters. And those letters are pretty much giving it a name. So we can, as far as the notation goes for this, you can either just refer to the letters. So we can say, you know, point A, point B, and point C. So we can refer to it that way. Or you could write out the word point. So you could say point A. So different ways that you could write it out. You could either just work with the letter itself. So point A. So you're just going to write down a capital A, or you could write out the word point. We do use typically capital letters to go along with our points. Next one is a line. A line is made up of points. It has no thickness or width to it, and there's exactly one line that goes through 2 points. So when you think of a line goes on forever and ever and ever. There is no beginning and there's no end to it. And in order to make a line, you have to have a minimum of 2 points. So if I just go ahead and say that points A, points A and B are on this line. You could have a line made up of more than 2 points. So we could put, say, X, Y, and Z on this line. And you can have a line that's made up of thousands of points, but rather than putting all those points down, we might just give it a name here. We're going to call this line L. So as far as the notation goes with your lines, you have really 2 options. You can either use the points on the line. So I can say here, okay, this line goes through points AB, so I'm going to use the points of AB. And then over the 2 letters, I'm going to put a line with 2 arrows on the ends. If you have a line that has more than 2 points, all you want to do is you want to pick 2 of the points. So this line that has X, Y, and Z on it, I could say that this is line XY. I could refer to it as YZ. Or I could refer to it as XZ. Sorry. As XZ. So there's 3 different ways. One we do not want to do here is we do not want to use all 3 letters. So we are not saying that this is line X, Y, Z. And we'll get into that a little bit more here in a little bit, more so with the idea once you start working with segments. And if you're doing it this way, you can be confused with a plane. So we just don't want to use 3 letters. We only want to choose 2 of them. Or your last option is to use name the line, so give it a name. So we like to use, you know, letters for doing that, and you'll typically see them as lowercase script letters, so you kind of see them as a cursive writing. And so here we can say that this is line L. So sometimes you'll just see a L written down, or you might see it written out as line L, either way. All right, so there's the information on the line. Next, we're going to go to a line segment. A line segment is a line with two endpoints, and a segment can be used, or can be measured in length. So you're still kind of thinking about a line here, but instead of a line going on forever and ever and ever, because it has no length that's to it, it goes on forever. A line segment has a beginning and an end, and so we have to have it begin and end with a point. So here we can say that it starts and ends with A and B. I can have a line segment have many points on it. That's not a problem at all. So I can say that we have points A, B, and C on this line segment. As far as your notation goes, just like a line, you're going to pick the 2 points that it goes through where it begins and ends. So I could talk about segment AB, and over the top of it, I'm going to draw a line with no arrows. If you have more than 2 points on your line, you're going to have to think about which segment are you referring to. I actually have 3 different segments I could refer to. I have segment AB, we have segment BC, and we also have segment AC. So all 3 of those segments are within these 3 points. Just like with a line, we do not want to use all 3 points. So I do not want to put segment ABC with a line over it. So we're going to stay away from that. All right, so 3 down. Next one is a plane, and a plane is a flat surface made up of points, at least 3 points that are not on the same line, and it extends infinitely in all directions. When you think about the piece of paper that you are currently writing on, that right there is a plane. The table that you are probably writing on, that is a plane. When you think about the room that you're sitting in, most likely it's made up of 6 planes. You have the 4 walls surrounding you, and you have the floor, and you have the ceiling. So when you think of a box or a Kleenex box, something like that, it's made up of planes. It's made up of flat surfaces. And how you'll see this sometimes drawn out is, we'll just kind of draw this little quadrilateral there, that parallelogram, and that just represents our plane here. Now what needs to happen in order to be a plane is it needs to have at least 3 points on it. And those 3 points cannot be on the same line. So if we name these points here A, B, and C, okay, those 3 points, we could say that this is plane ABC. So we could, that's how we're going to note it, plane ABC. That's why we do not use 3 letters with lines and line segments, because then it can get confused with a plane. Now, if I were to look at this plane right here, and I was to draw a line with A and C here, and let's say I put a point X on there, I cannot say that this is plane BXC. And the reason I cannot do that is because B, X, and C, they are all on the same line. So they got to be on, they cannot be on the same line. It's just got to be 3 points on the plane. All right, so I know on that foldable right there, that first one, you still have 2 spots. You've got the angle and the ray, which we're going to get to in just a moment or two. I'm going to have you go to the second foldable, where I'm going to have you write down 3 new definitions, or one of them you may recall: linear, collinear, and coplanar. So the word linear means that you're drawing a straight line. You probably think back to your algebra days, and when we talked about linear equations, y equals mx plus b, that was a graph of a straight line. We have the word collinear. Collinear means that you have multiple points that are on the same line. So since a line is made up of 2 or more points, 2 or more of those points have to be collinear. They have to be on the same line. Then you have the word coplanar, and coplanar means that you have points that lie on the same plane. So collinear, coplanar, that root word of co, okay, and then you can see the linear for a straight line and planar, which is representing the plane. Now I'm going to take a moment to use the information we talked about above and get into a little bit about line segments. So line segments you're going to see a lot of, because what we can do here is we can actually give line segments a length to them. We can actually measure them. We cannot measure out a line. And so if I look at this segment right now, we could go ahead and say that this is segment AB. And so I'm going to say that here we have line segment AB. And that's what that notation is that we just talked about. Now what's going to happen is you're going to see this written out in a different notation. And what you're going to do here is you're going to see that there's no line over those 2 points every once in a while. So you're just going to see an AB. What that's talking about here is it's talking about the measure of segment AB. And so what I'm referring to here is if I was to look at this segment here and I'm working on a problem, you might see something like this where it tells you what the length of that segment is. So I could go ahead here and say that the length of AB is equal to 10 centimeters. Now in geometry, including units is always going to be very important. So make sure that you're always including units. Sometimes it might just even be units. If I didn't have that 10 right there, it would be 10 units. But the fact that when we look at this AB here, this is referring to the fact that this is the measure of AB. So the measure of segment AB is 10 centimeters. I am not using the line over it. Now that's not something I'm going to be super picky about, but you'll notice that you know, sometimes I'm going to use the line and sometimes I'm not going to use the line. All right, then in getting into line segments, we need to cover 2 other terms, and that is the word congruence and congruent segments. When you're talking about congruence, what that means here is that we just have equal parts. And congruent segments means that you have 2 or more segments that have the same length or the same measure. All right, so congruence means that you have equal parts. Now if I go ahead and I take this segment right here and I put a 3rd point on here, so I'm going to go ahead and make that point X. In geometry, what we do is we use these little markings to represent congruence. So these little red dashes they're both red, they're both about the same length here. What that's doing here is it's saying that the length from A to X is the same from X to B. So we can write this out in 2 different ways. We can say that AX is congruent to XB, and I'm going to use my lines because I'm talking about the actual segments, or what you can do here is you can say that the measure of AX, so I'm not using a line, is equal to the measure of XB. So two of these is different. One of these is talking about the congruence statement, and the other one is talking about the measure statement. So this one right here is a congruence statement. And this right here is talking about the measure. And so looking back up at my my diagram that I have here, from A to X and X to B is the same. If the length from A to B is 10 centimeters, well then that right there has got to tell me that the length from A to X, sorry, these just kind of jumped off here. Sorry. I gotta switch pages real quick. Okay, hopefully you got that before it jumped off of there. But if that whole length right here is 10 centimeters, then that's referring that AX would then have to be 5 centimeters, and XB would also have to be then 5 centimeters, because the whole segment has to be 10 centimeters, and we know that those two have to be equal to each other. All right, so moving on to the next part here, and that is we're going to talk about array. So array is a line with one endpoint that extends indefinitely in one direction. So when we're talking about array, what that looks like is we have one endpoint and then a line going into a direction here. Now when you get into physics, you start talking about array and you start looking at more of like a vector. Here we're just going to be looking at this point and drawing it out. When you have array, you typically definitely has to have one endpoint, so we'll say that A, and then we're going to want to have another point on there so that we can help give this array a name. And the name that we're going to do here is we are going to use those 2 points and then put a line with just one arrow over the top. The beginning of your line right here should go over where the endpoint is. Alright, and I'm hoping I can keep this video under 20 minutes. That's my goal. So I'm going to go ahead and move on here to an angle. An angle is formed by two rays that share a common endpoint. So an angle has two rays. There's my common point right here. And we'll give that a name so we can say that this is A. One way that we can name an angle is we can refer to it as angle A. So it's kind of like a slanted L that's being used for that. Another way that we can name an angle is we can go based off of 3 points. So if I use X, Y, and Z, we can say that this is angle X, Y, Z. And the main thing here is you just need to make sure that that point that's at the vertex, which is at that endpoint, has to be here in the middle. And another way that you can name angles is sometimes you'll see them numbered. So I could put, say, like a number 3 right here, and you'll see that this is angle 3. Eventually I will like to use that because it's a lot easier and faster to do and refer to. But sometimes you can get away with angle A, but sometimes we have to be more specific in our angles. All right, so there you are. Kept it under 20 minutes, just barely. But make sure you bring your notes and everything with you to class tomorrow, and we will use all this stuff and play around with it a little bit more. So have a good night.